Some parts of the world have terrible problems with drought, but at home it's the other way round. How many things can you think of around the house that need drying out? How do we get things dry? And what do we mean by drying out? Put a drop of water on a hot plate and it fizzes and disappears. Drying out is very fast when the water gets hot. Now the metal isn't so hot. Still, the water is fizzing or boiling, but water can dry without boiling. This is called evaporation. Water in a beaker gradually dries out. The water evaporates and water vapour goes off into the air. When nail varnish is spread out, the solvent evaporates. That's why the nail varnish dries. How can you get water to evaporate from wet clothes or hair? What could have evaporated all the water and turned this land into desert? And why do you think nail varnish dries more quickly when it's spilled out than when it's in the bottle? There are many things that affect the speed of drying out. Let's try and find which ones are important. Nail varnish dries quickly when it's spread out, when there's a large surface area exposed to the air. What about the temperature? Hot water dries more quickly than cold water. Hairdryers use heat, but they also use wind. Can you guess how this might help? These scientists are using wet towels to study the effects of surface area, wind and heat. Every minute they take the towels down and weigh them to see how much water has evaporated. This pair are looking at surface area. The red towel is hung on the line folded so that only a small surface area is exposed to the air. Both the towels are the same size to make it a fair test, but the green towel is spread out to expose as much area as possible. They plot graphs of mass against time. The mass of the damp towels gets less as the water evaporates. The spread-out towel dries quite quickly because lots of water is evaporating. But the folded towel dries much more slowly. Can you work out why? The next pair are using a fan to blow air at one of the towels. The other is hung up spread out, but with no wind. A graph of mass against time shows that the spread-out towel dries as quickly as it did before, but the towel in the wind dries faster still. The third pair are testing heat. An electric fire warms one of the two towels. The spread-out towel dries as it did before. What about the hot towel? So there are three things to remember. Water evaporates more quickly when there's a large surface area, when there's wind, and when there's heat. How would knowing this help you to store a lot of water in a reservoir? You don't want all the water to evaporate. If you can put the reservoir underground, evaporation is kept to a minimum. But that's very expensive to build. Usually, reservoirs have to be built in natural valleys. Suppose you had to design a reservoir to supply the water for a big town. What sort of valley would you choose? A wide, shallow valley like this one? What problems of evaporation might there be? What about the surface area? In a steeper-sided U-shaped valley, the hills are higher and the water is deeper. What difference will this make? What about the trees? Will they help by giving protection from the wind? Sometimes it's possible to build reservoirs in deep V-shaped valleys between mountains. Which sort of valley would you choose if you wanted the least evaporation? And what other problems should you have in mind? When cold things are exposed to damp air, you sometimes get condensation. That's why things often steam up in the kitchen. When the air is damp, full of water vapour, cold surfaces get steamed up. In the bathroom, too, the air is often damp and full of water vapour. When this water vapour hits a cold surface, it condenses. That is, it turns back to little drops of water. Is condensation ever a problem in your home? Water vapour from the kettle is condensing on the cold metal plate. This is how rain forms. The water vapour in the air condenses into clouds, and if all the little drops come together to make bigger drops, they fall down as rain. clouds are condensation. Condensation from the water vapour in the air. In this speeded up film, you can see the water vapour condensing into clouds. Millions of tiny drops of water swirling in the wind. If the tiny drops run into one another, they make big drops, which fall out of the clouds as rain. Plenty of fresh water. But what if there isn't any rain? How can you get fresh water then? If you're by the sea, it's possible to make fresh water from salt water. Can you think how this could be done? This is a desalination plant in Israel. Inside, seawater is evaporated to make water vapour. Then the water vapour is condensed to make fresh water in the desert. If you're a long way from the sea, it's not so easy. One remarkable new idea is to make rain with an artificial cloud. This cloud is a giant plastic bag. It inflates itself with the heat of the sun. The idea of scientist Graham Stevens is that when it's flying above the desert, the underneath will be cool. If damp wind blows under it, water vapour should condense on the underside of the cloud. If it's successful, the condensation should trickle down to make rain in the desert. Do you think it'll work? When it happens inside a house, condensation can be a real problem. What happens when a house gets too damp? Wallpaper often suffers if the house is too damp, and sometimes it gets so bad that even your clothes go mouldy. How can you deal with too much damp in the house? And what precautions can you take to prevent it? The opposite of condensation is evaporation. Remember, evaporation is helped by wind and heat. If you can keep the house warm, it won't get so damp. But paraffin heaters produce a lot of water vapour, and to stop that condensing, you must also provide ventilation. Double glazing is meant to keep out drafts. One problem is that it can be too good and cut out ventilation altogether. That's why you need air bricks. Air bricks ventilate the house and help to cut down condensation inside. Why do you think kitchen windows are often fitted with extractor fans? When there's a lot of water vapour about, one way of dealing with it is a dehumidifier. Let's have a look inside. Inside the dehumidifier, there are cold metal fins. The water vapour is sucked in by a fan and condenses on the cold metal. From there, it trickles down into a box below. The earth is usually damp, and water can soak up from the earth into the walls of a house. So houses are built with a damp-proof course. This is a thin layer of waterproof material that goes between the bricks. See if you can spot the damp-proof course in houses near you. It's usually just above the ground and below the doors. The makers of cameras and other delicate equipment take care not to let their products get damp. One way they do this is by putting a packet of silica gel in the box. There might be water vapour in the box, but silica gel crystals absorb water vapour. They soak up water vapour from the air and stop the camera from getting damp. How do you think talcum powder works? What fair test could you do to compare talc with silica gel? People who go jogging get hot and sweaty. If they wear the wrong sort of clothes, the sweat can't evaporate. That can be most uncomfortable. What you need is clothes that can breathe and let the water vapour out. Different materials have different sorts of properties. Some are much thinner than others, but they might be no good for making clothes. Can you think of a fair test to compare different fabrics and find out which ones let water vapour through easily? This is one way of doing it. Measured amounts of water are put into small jars. Then the top of each jar is covered with one type of fabric. Each jar is weighed at the beginning of the experiment and then again later. The figures go down, but by different amounts. Can you explain why? Look at these highly magnified pictures of cotton Ventile and Gore-Tex. These fabrics breathe. They let water vapour through, but they're still waterproof enough to keep the rain out. A good raincoat must stop liquid water from getting through. It has to be waterproof. But if it's going to be comfortable, it also has to let water vapour out. It must breathe. What tests would you do to find out which fabrics are waterproof and which ones can breathe?